Hello, everyone, and welcome back from the break. Next up, we have Weiser Hasse from DeFi Wonderland, who will be presenting on their cross-chain Oracle. Welcome, Weiser.
Hi, everybody. This is Weiser from DeFi Wonderland. And I wanted to share with you a product that we made and the learnings that we got since the development of that. It's cross-chain Oracle that it uses UniV3 as a source of truth. So I wanted first to talk about like who did we build it for, because I think it's important because it's like what's designed to do. There was this talk before that said like there's no perfect oracle. You have to know like who are you building to. So let's take a minute to understand like what's the Keeper network that we built it for them, and I think like there's some misconception about like the Keeper network, because I don't think it's an automation protocol. It's an automation payment protocol. So the way it works is that if you need something to be automatized, you deposit a liquidity in UniV3, and then the protocol like generates credits with time for your protocol to pay for automation. So a keeper, that it's a bot, it's going to call your contract to run this task that you have to automate. And the protocol, and this keeper protocol is going to go into the UniV3 pool, quote the like the gas price, because the keeper is spending ETH and is receiving this token. So he needs a quote, and the thing that I think is very interesting is that the same payment method that the shop has, it's used to provide liquidity in the pool that the protocol is using to read the quote back. So it's a kind of a very nice circle in which the jobs provide exit liquidity for the bots, that they run the transactions, they spend the ETH, they receive the tokens, and they go to the pool and dump their tokens. So in a way, like the spot price is irrelevant, but it just like keeps on going. So at some point, we wanted to do this multi-chain. And we decided that we didn't want to fragmentize liquidity because there was very low liquidity enough in mainnet. So we had to do this like in a way that it wouldn't require the same infrastructure that we had on mainnet in any other chain. So what we wanted to do is to breach a quote every 5 days, because the protocol has like this tick that every 5 days it gets updated because of the quote of UniV3. So we had like the simplest cross-chain task that you can imagine. Like every 5 days, just like send the twap, and the protocol in the other side is going to work like completely the same. So at some point we say like, okay, we like just breach the quote, we deposit the liquidity in mainnet, we breach the token, and it's all going to work like just fine. But the thing is that we are starting asking questions about like, what if the quote doesn't arrive by the 5th day? So we had to make some modifications. What if like the quote doesn't ever arrive? So we needed to make like everything revert, and we needed to make the protocol like adapt to that. So at some point we were making so many changes into the core contracts and we realized that what we needed to change was not the core contract, but the oracles. So our solution was to just copy the UniV3 pool in the other chain. This was done before Uniswap open sourced, but that's why we're anons. So we decided that what we needed to have is a contract in the other side that is always alive, that it gets like updated, and whenever the tick arrives, it just like reads the 5-day track of history. What happens if the new history doesn't arrive? We just read a 5-day swap and it's going to work. It's not going to revert. Maybe it's outdated. It happened in the history of this oracle. But it worked, and it didn't revert. It just like was outdated. So what we do is we have this pool on mainnet, we read the story, and we send it into a copy contract that it's like exactly the same as a UniV3 pool, but it doesn't allow any swap. It doesn't have like any liquidity, but it has like the same Oracle library that stores the Oracle history tick by tick. And the interesting part is, I think, how did we do it? So if you are keen on UniV3 white paper, I think like this is one of the most revolutionary ways of storing this data, because what Uniswap does is it doesn't store the tick at some point. It stores only the slot 0. And by storing the tick cumulative, you can, from some way, like get the whole history. But how do you do that? What Uniswap stores is the tick cumulative, that is the integral of the tick with time. So we try to figure out like how to read this, because if not, we have to go to every storage slot that Uniswap swapped, and we have to do that on mainnet, which is like quite expensive. So what we did was understand that if we calculate the swap, we are being able to get and recover the whole history. So if you get a little bit of math, you'll realize that the tick cumulative history is just the integral from 0 to now, from the tick times the time that it happened. So by knowing that, you can know that you can calculate the swap from whatever point A and B, and the time difference that you have, and you're going to be reconstructing the whole tick cumulative history by saying the swap from 0 to A, the swap from 0 to B, and what it does is it extrapolates the last information that it has, that in Uniswap it's true, because it says that the tick hasn't changed. And the interesting part is that you can choose arbitrarily whatever point 0, A, B until the X or Y, and it's going to be true. So this is what we're leveraging to try to compress the information that we are sending and try to write it down in the other side. So I wanted to share a couple of the mechanisms that we have, that we arrived to this because of iteration. And the first thing that we needed was a source of truth in mainnet. We needed to have a contract that reads the Uniswap pools, that says like, hey, this is the truth, and bridges to the side. At some point at the start of the project, we said like, okay, we query the Uniswap pool, we bridge it, and then we started questioning like, what if the message doesn't arrive? We have to re-query the pool and re-bridge it, and how do we know that? So what we did in this contract was there is reasons why we needed to update the history. That is like either one day has passed, or either the price has gone up or down more than a threshold. So we say like, okay, we need to update the history, because this is not updated anymore. This is not true. We need to update it. So we query a pool, and then what we do is do not bridge at all. We just like kekak this information, and we store it on chain. And that's it. So the next part that happens is that whenever one of these bots wants to work, because we are working for an automation protocol, so we know a little bit about automation, these bots are going to just like read the events, and they are going to bridge those events through the data feed, and the information that these people send, it's going to be like either information that the data feed has read, or it's going to be reverted, because we are kicking it and then comparing to the known information, and if it doesn't match, then it's fake, and if it matches, we can bridge it to the other side. Now, there is a couple of things that are very ad hoc, that is the bridge adapters. because we were figuring out like we need some source of truth, we need some receiver, but in the middle, every bridge works like on their own way. Like there's no standard for bridging. So we try to make like the whole mechanism bridge agnostic. So we said like, okay, as we can have like one bridge that is connects, we can have like whatever another, but the important part is that we share the source of truth and the receiver. And in the other side, the information arrives and the data receiver says like, hey, do I know this pool? No. If I don't know this pool, I'm going to deploy one of these like virtual Unity3 factories, Unity3 pools, and I'm going to insert the data. If I know this pool, I'm going to try to update the data. And if the nonce, it's not the next one, it's going to revert because we need this data to be sequential. So at some point, we arrived to this oracle that it's not so incorrect in a way, because it's always showing fact true. It's only sometimes like a little bit delayed. But if it's too delayed, we are enabling that it updates. And if it's too incorrect because the twap changed, we are enabling that somebody pushes the information. It's always available. It's never going to revert. And we can query exactly the same as a Unity3 pool because it's the same contract. So how does this work? Real on-chain, this is information about the last 14 days. And you can see that the green line represents, I don't know, I don't think it's, yes. The green line represents like what's in mainnet, what's the source of truth, and the other lines represent like what information arrived to the sidechains. So in the graph below, you can see like the error at each time, and this is for the spot quote, 1 second twap. But when we go to longer twaps, we can see that it starts like to follow it, and the error it gets is not more than 2%, because we set the max error to be at 2%, and when there's 2%, we allow the oracle to update and bridge back. So at some point, we are like capping the error, and I think the most beautiful that happens is that we go to one-day twap, you start seeing that the lines follow each other, and that we are not missing the quote by 1%. So how does it work when there's a big pump, when there's a jump in the price? And you can see in the right one that not even 1 day has passed, but we updated the quote like 1, 2, 3 times because we needed it. Because we needed to have the 8-hour twap within a 2%, so it triggers 1, 2 again until it works. And the most interesting part is how much it costs to have an oracle like that. At this point, the oracle is fed, this whole mechanism is fed with what we call 13 KLPs. That is this liquidity that you deposit in Keeper protocol, that they have a value of 8K. And in the last 6 months, this whole oracle spent 6 ETH from these bots, and they rewarded them. But the whole cost that we had was having this money frozen in this protocol. Like for us, it takes like not more money. We don't have to actively top up. We just like left these KLPs, and it works with time.